Hi everyone, welcome to ICP-DAS webinar. This is Joyce from ICP-DAS International Sales and Marketing Division. Today, I will share how ICP-DAS integrated factory solution can help you conduct equipment monitoring and ensure your factory safety. In the following, we will dive into 4 case studies centered on factory automation and IIoT, including the intelligent cooling tower status monitoring, advanced vibration monitoring of process equipment in a steel plant, preventive maintenance and EMS for air compressors, and temperature monitoring in factories. Let's have a look at the first case study, intelligent cooling tower status monitoring. Cooling towers play a crucial role in heat dissipation during the production process. It utilizes water and cooling fans to drive hot air upwards, releasing it into the atmosphere to lower the system temperature. This technology is not only applied in chemical plants, but also widely used in refineries, thermal power plants, and nuclear power plants. The client in this case is a chemical plant. They are primarily engaged in the manufacturing, processing, and handling of chemicals. The plant is equipped with essential equipment such as boilers, distillation columns, reactors, and cooling towers to produce high value-added products. The customer wanted to build a monitoring system to ensure the smooth operation of their cooling towers. So how can ICP-DAS help in this case? With holistic product lines, we offer a total solution that combines DAQ, conversion, and communication. By utilizing this solution, ICP-DAS help achieve data collection, real-time performance analysis of the cooling tower, fault diagnosis of the fan drive system, and damage identification in the cooling system. This system structure is divided into 2 key sections, each addressing a different aspect of monitoring and data collection within the cooling system. The first section focuses on collecting analog data from various sensors, such as pressure sensors, thermometers, and current sensors. The second section highlights vibration monitoring for cooling fans. In this case, the customer used ICP-DAS I87000 series I/O modules combined with ET87PA MTCP I/O expansion unit to collect the data of the cooling tower, including hot water and cold water temperature, wet bulb temperature, outlet pressure, and liquid level, as well as the motor current of the cooling fan. The customer used ICP-DAS I87017 ZWG analog input module to collect the data on the outlet pressure and liquid level of the cooling tower, as well as the motor current of the cooling fan. In addition, the I87015 PWG RTD module was used to collect the data on the temperature of the wet bulb and the water. The I87017 ZWG analog input module provides 10 differential or 20 single-ended input channels with 16-bit resolution. Each channel can be configured individually for voltage or current input. The I87015 PWG RTD input module provides 7 RTD input channels and supports 3-wire RTD resistance elimination function, ensuring accurate measurements regardless of wire length. In this case, by comparing the outlet water temperature with the cooling limit of the cooling tower, the wet bulb temperature, the cooling performance can be assessed. The ET87PA MTCP is an Ethernet I/O expansion unit designed for Modbus TCP applications. It provides 8 I/O slots for expanding ICP-DAS I87000 series I/O modules over Ethernet, making it suitable for various industrial monitoring applications. The unit features two Ethernet ports to create a daisy chain topology, allowing multiple ED87PA MTCP I/O expansion units to be connected in series or linked with other Ethernet devices for centralized wiring. Furthermore, this module supports Modbus TCP, Modbus RTU, and ASCII communication protocols, and includes a gateway function for converting Modbus TCP to Modbus RTU. In Section 2, the customer used ICP-DAS PETAR400 PoE Ethernet high-speed data acquisition module to retrieve the vibration data from the cooling fan system's gearbox and motor, collected by the IEPE accelerometer. The PETAR400 Ethernet high-speed data acquisition module provides 4 analog input channels and enables simultaneous multi-channel data acquisition. Its sampling rate is adjustable, with the maximum of 128 kHz per channel. Additionally, it supports 2 data trigger modes, software-triggered and analog input threshold-triggered. In software trigger mode, data collection can be initiated via commands to gather continuous or end data samples. In analog input threshold trigger mode, the data collection is triggered to capture end data samples when the analog input value exceeds or falls below the preset voltage threshold. For IEPE accelerometers, you are not limited to using ICP-DAS products. You can select the IEPE accelerometer that best meets your specific requirements, even if it's from another brand. The key is ensuring it aligns with the standards we've listed here. As long as it meets these specifications, it will seamlessly integrate with our data acquisition module, allowing you the flexibility to customize your solution without compatibility concerns. The GRP540M 4GE Ethernet 0 CAN to 4G gateway converts Ethernet, RS-232, RS-485, and CAN wired communications into 2G, 3G, or 4G wireless transmission. Besides, it features the GPS functionality, enabling location tracking for mobile device applications. In this case, the GRP540M 4GE Ethernet 0 CAN to 4G gateway uses 4G communication to transmit data from the I87017 ZW analog input module, the I87015 PWRTT input module, and the PETAR400 Ethernet high-speed data acquisition module back to the control room for data analysis and management. ICP-DAS Intelligent Cooling Tower Monitoring Solution offers clients a comprehensive way to collect and transmit real-time data to the concentrator, enabling remote monitoring and quick responses to abnormal conditions. This minimizes downtime and ensures timely interventions. Management teams can further analyze the collected data to proactively plan preventive maintenance and strategies, reducing future risks and breakdowns. As a result, operational efficiency is significantly improved, ensuring a more reliable and optimized cooling tower system. Here comes to the second case study: Advanced Vibration Monitoring of Process Equipment. The customer is a steel plant with a large array of complex equipment used in raw material transportation, steel making, and hot and cold rolling processes. During production, if any motor experiences a failure or breakdown, it will halt the entire production line, and the unfinished products must be discarded. This resulted in reduced overall productivity, increased costs, and potential workplace hazards. To reduce these risks, the customer aims to proactively monitor bearing vibrations and perform early maintenance on the equipment to minimize losses and ensure the safety of the production line. The following explains how this client used ICP-DAS equipment vibration monitoring and predictive maintenance solution to achieve real-time vibration monitoring of process equipment. ICP-DAS equipment vibration monitoring and predictive maintenance solution utilizes the AR series accelerometer data logger to record and recalculate the machine vibration values and set vibration threshold levels. The VPD series HMI retrieves the data via the Modbus TCP communication protocol for real-time display. The data is then transmitted through the ET7000 series I/O module via Modbus TCP and subsequently forwarded to the PLC. This is the smart upgrade for traditional PLCs, enabling the PLC users to monitor equipment vibration through current readings. Additionally, if the VPD series HMI detects abnormal vibrations, it triggers the ALM series sound alert module via the ET7000 series I/O module. The ISN IEP accelerometer is used for vibration measurement, with the measurement range of -80 G to 80 G and a frequency response range from 0.5 Hz to 15 Hz. In this case, the customer installed an ISN 701 F15L030 IEP accelerometer at each end of the motor bearings. Then, the collected vibration data is transmitted to the AR400 accelerometer data logger. The AR400 accelerometer data logger offers one digital input channel and 4 analog input channels, capable of simultaneously collecting data from up to 4 IEP accelerometers. Each analog input channel supports a maximum sampling rate of 125 kHz. All captured signals are stored on its built-in 4 to 32 GB microSD card for offline vibration analysis. In this case, the AR400 accelerometer data logger calculates vibration features such as peak-to-peak acceleration on RMS velocity, and sets vibration thresholds based on the signals collected by the IEP accelerometer. The VPD series Touch and My device is equipped with an IP65 rated enclosure that ensures stable and reliable operation in harsh environments, such as steel plants. And it features a rubber keypad that allows operators to use it while wearing gloves. The VPD series Touch and My device features a high-resolution color touchscreen available in 3.5, 4.3, or 7 inches. It comes with the built-in communication interfaces, including RS-232, 485, and Ethernet, and supports standard Modbus TCP and RTU protocols. This allows for a seamless integration with various devices. In this case, the VPD module is installed outside the control panel to display the real-time vibration data, including peak-to-peak acceleration and RMS velocity. Also, the VPD module uses the threshold values to determine if an alarm should be triggered. The ALM04 MRTU MP3 alert module features 4 isolated digital input channels, 1 relay output channel, 1 MP3 audio line output, and 8 alarm modes. Also, it includes a built-in micro SD card for storing up to 64 pre-recorded audio files. If an alarm is needed, the VPD module sends a signal to the ET7224 Ethernet I/O module via the Modbus TCP protocol. The DO channel of the ET7424 then activates the ALM series MP3 alert module. Additionally, the VPD module uses the ET7224 Ethernet I/O module to output the current values to the PLC, allowing the PLC to monitor the machine's vibration status in real time. The ET7224 Ethernet I/O module features 4 analog output channels, 5 digital input-output channels, and 2 Ethernet switch ports, enabling daisy chain topology configurations. It provides programmable analog output options, which can be set via jumper settings. The AR400 accelerometer data logger plays a key role in vibration monitoring by capturing raw vibration signals and calculating critical vibration features along with fast Fourier transform spectrum values. This data is seamlessly transmitted via the Modbus TCP protocol to controllers and HMIs for further integration, enabling real-time monitoring without overloading other control systems. By providing early diagnostics, this solution allows for preventive maintenance, helping to minimize unexpected equipment failures, reduce downtime, and ensure more efficient system operation. Next, we present the third case study, preventive maintenance and EMS for air compressors. In Taiwan, the government mandates that electricity users consuming over 800 kW must implement energy-saving measures, monitor all factory power usage, and upload the collected data to a government system for compliance. Previously, this customer relied on manual recording of power consumption, which often led to errors, making power management difficult. Additionally, routine inspections for air compressors resulted in premature or delayed maintenance due to the inability to monitor the operational status accurately. To address these issues, ICP-DAS provides an all-in-one solution integrating power consumption monitoring with air compressor status tracking. This achieves a seamless combination of energy management system and preventive maintenance. We can divide this system structure into 2 parts, machine status monitoring and power consumption monitoring. Let's start with the first part, machine status monitoring. ICP-DAS uses the PMC5231M4GE power meter concentrator to retrieve air compressor status data from the PLC and applies logical controls to set warning thresholds. The collected data includes the compressor start and stop status, operating hours, oil replacement intervals, and alarm conditions. When preset thresholds are reached, the PMC module automatically sends notifications via the Telegram app to maintenance personnel's mobile devices, enabling timely on-site maintenance for the air compressors. Let's move on to the second section, power consumption monitoring. The PMC5231M4GE gathers cumulative airflow data from flow meters and power usage information from the PM3133 power meters. By calculating the efficiency value, the customer can understand how much energy is consumed to produce 1 cubic meter of compressor air. This efficiency value is calculated and sent to the customer via the Telegram app for review at the start of each month. In addition to machine status monitoring and energy management, ICP-IoT Star IIoT cloud management software provides a centralized dashboard displaying critical compressor data. Customers can remotely monitor equipment status in real time, even from their office, and analyze historical trends to make data-driven decisions and optimize operations. In this case, the customer utilized the PM3133 three-phase smart power meter with clip-on CT for easy installation. ICP-DAS offers a wide range of power meters tailored for various needs, including single-phase and three-phase options, isolated and non-isolated models, different loop selections, and flexible CT or Rogowski coil installations. Additionally, options like LED displays further enhance usability. This variety enables customers to select their ideal combination to meet their specific power monitoring requirements effectively. In this case, the customer installed the PMC5231M4GE power meter concentrator to integrate multiple power meters and machine status information. Users can finish the setup without the need for programming. Another standout feature of the PMC power meter concentrator is its if-then-else statement capability, which allows it to activate related equipment during emergencies. Additionally, it can issue real-time alarm notifications through Telegram or email, ensuring swift responses of maintenance personnel through critical situations. The PMC module offers a variety of real-time and historical power analysis charts. In the top left, there is a real-time voltage line chart. In the top right, historical power consumption is analyzed by comparing the same season across different years to observe changes. The bottom left shows power consumption proportions, allowing multiple meters to be grouped and their usage ratios displayed. The bottom right displays PUE, or a Power Usage Effectiveness chart. You may wonder what is PUE. PUE is a crucial metric to measure energy efficiency in data centers. It compares the total facility energy consumption to the energy used by IT equipment. As we can see in the table, the lower the PUE value is, the better the efficiency is. A PUE nearing 1 signifies an efficient data center, where most energy supports IT operations with minimal energy wasted on cooling, lighting, or other infrastructure. This metric is vital for assessing and optimizing energy performance in data centers. The PMC module also provides power reports for different time periods. Users can easily view these reports online or export them as Excel files for further analysis. The IoT Star cloud management software offers 5 main functions to enhance connectivity and data management. The remote access service enables users to update the firmware for the connected controllers, ensuring devices stay up to date. The sensor data service logs the collected data into cloud databases, including MySQL, SQL Server, and Oracle for streamlined storage and retrieval. The dashboard service visualizes data through user-friendly charts. The report service generates PDF or Excel reports for further analysis. Lastly, the Lightbar service allows users to query sensor data and receive notifications via Line or Telegram apps. To help you quickly identify EMS solutions tailored to your needs, ICP-DAS offers this user-friendly roadmap to help you navigate through various options easily. Whether you are looking for power meters with different loop configurations, single-phase or three-phase capabilities, multi-circuit features, or even LED displays and various transformer sizes, we've got you covered. Additionally, it covers essential tools like reporting and management software. With this roadmap, you can quickly find and implement the ideal power management solution. By adopting ICP-DAS solution, the customer reduces energy waste and increases the energy efficiency of air compressors by 15%. They also minimize unexpected downtime by identifying issues proactively and conducting preventive maintenance in response. The IoT Star dashboard further enhances operational visibility, allowing management personnel to easily monitor real-time data on a centralized screen, enabling quick and informed decision-making. Additionally, the comprehensive power consumption monitoring ensures compliance with government energy regulations, providing a seamless and reliable approach to managing energy usage across the entire facility. Here comes to the last case study, temperature monitoring in factories. Reports of electrical control cabinet catching fire are becoming increasingly common, posing serious risk to both personnel safety and production continuity. For this reason, the customer sought to implement a reliable monitoring solution to safeguard their factory's control cabinets, production lines, and warehouses. By introducing a system capable of detecting potential hazards in real time, they aim to prevent accidents before they occur, ensuring a safer working environment while minimizing disruptions to their production processes. The solution ICP-DAS offered to this customer combines comprehensive monitoring capabilities for machine temperature, vibration, power consumption, and environmental temperature. This all-encompassing approach ensures a safer and more efficient production environment. When an emergency occurs, the system promptly sends instant notifications to the relevant personnel so that they can take swift action and troubleshoot issues immediately. Meanwhile, to keep on-site personnel updated on real-time situations, the ICANN series LED display shows critical data on the factory floor. To go into details, we can divide this system structure into two sections. Production line monitoring, which focuses on ensuring the smooth operation of machinery, and supply chain monitoring, which emphasizes the safety of conveyors and storage environments. This approach enhances the factory safety and operational reliability. Temperature, vibration, and power monitoring can enhance workplace safety and reduce failures and defective products. In this section, the ISN A11C MTCP IR temperature sensing module monitors the temperature and real-time image of production line equipment and the control cabinet. The AR300T accelerometer data logger monitors machine vibration data, and the PM2133D MTCP power meter collects the power consumption information. All the data are transmitted to the WISE 5231M4GE edge controller that sends notifications to the relevant personnel if necessary. The stability of raw materials and logistics is closely related to the workplace safety and product quality. So it's very important to keep the relevant personnel updated on the storage environment. In Section 2, the ISN A12 MRTU IR temperature sensing module monitors warehouse and conveyor temperatures to secure raw material management. The ALM series alarm siren is installed to issue sound and light alarms when an emergency occurs. Additionally, the MDC714I Modbus data concentrator compiles all the obtained data and sends it to the Aviva Edge SCADA via Ethernet or for further analysis. The AR300T accelerometer data logger provides 3 IEP input channels, and it allows simultaneous multi-channel data collection. Compared to the AR400 accelerometer we mentioned in the previous slides, the AR300T module provides one extra function: one channel of thermistor input. The sampling rate of the AR300T module is also adjustable, with the maximum of 125 kHz for each channel. All collected signals are stored on its built-in 4 to 32 GB microSD card for offline vibration analysis. ICP-DAS ISN 800 series IR temperature sensor uses the non-contact thermal imaging technology to monitor the temperature inside the control cabinets, providing an alternative way for the maintenance personnel to reduce inspection time and the risk of unexpected equipment shutdown with minimal intervention. For communication protocols, the ISN A11C MTCP supports Modbus TCP, MQTT, and RESTful, while the ISN A12 MRTU module supports Modbus RTU protocol. For the measurement distance, both modules support 1 meter. The measurement range of the ISN A11C MTCP is -20 to 250 degrees Celsius, and that of the ISN A12 module is -40 to 300 degrees Celsius. Last but not least, the biggest highlight of the ISN A11C module is that it includes a built-in camera, so it can provide on-site snapshots aside from thermal images. This helps relevant personnel identify the location of an anomaly much more quickly. As the picture shows here, with thermal imaging sensors and visible by cameras, the ISN A11C MTCP module overlays 2 types of images for faster and more accurate problem detection. This makes it an ideal choice for identifying electrical anomalies, detecting mechanical overheating, and conducting equipment inspections efficiently. Our WISE series Edge controller provides an easy-to-use web interface. Users can finish the setup without the need for programming. which reduces the development costs. Another highlight of the Y series is its if-then-out statement capability. With the if-then-out statement, if an emergency occurs, no matter whether the Y series is connected to the monitoring software in the control center, it can activate relevant equipment immediately based on the preset configurations. Meanwhile, it will send alert messages via Telegram and email, ensuring instant responses to critical situations. The built-in data logger within the Y series provides a data recovery mechanism. When a network outage occurs, the data will be stored in the data logger. After the network resumes, the Y series will retransmit the stored data to the control center again. This avoids data loss. Moreover, it supports multiple cloud platforms, including Microsoft Azure and IBM Bluemix. The MDC700 series Modbus data concentrator can connect RS-232 and 485 devices to Ethernet, enabling seamless integration. The MDC700 series Modbus data concentrator reads data sequentially from Modbus devices using user-defined commands and consolidates the collected data into a continuous address format. This allows a host computer to read back the data of multiple slave devices at one time for unified management, replacing the previous pooling method and thus reducing data retrieval time. The overall system performance is improved as a result. Additionally, the MDC700 series enhances system scalability, making it a reliable choice for expanding and managing large-scale operations. In this case, it collects Modbus RTU data from the ISN 800 series IR temperature sensing modules and alarm sirens. The data is then sent to the host computer using Modbus TCP protocol. In today's webinar, we saw how ICP-DAS enable real-time monitoring of the cooling towers in a chemical plant to ensure smooth operations. In a steel plant, advanced vibration monitoring allows maintenance teams to predict and prevent equipment failures. We also dive into an all-in-one solution that integrated power monitoring with air compressor status tracking to enhance efficiency. Lastly, we discussed how temperature monitoring improves safety across production lines and warehouses. These stories showcase the benefits of factory automation and IoT in transforming industrial operations. With ICP-DAS comprehensive product lineup, your needs for industrial data acquisition, communication, conversion, and system integration can be addressed. ICP-DAS offers a wide range of products, from sensors, I/O modules, communication devices, controllers, to management software. With all these products, we provide one-stop solutions that can be applied in various fields, especially for industrial automation. This year, we also plan to have much research on cybersecurity topics as we receive some inquiries from you about the IEC 62443 standard. We'll keep you updated as soon as we have new insights or solutions to share. Thank you for participating in our webinar today. Don't forget to scan the QR code and complete the questionnaire. We will send you this PowerPoint file after you complete it. Now we're moving into the QA section. If you have any questions, please feel free to leave your messages in the chat. Thank you.